Let's talk about uncertainty of measurement. Now, let's say that you're a jeweler and you look up the cost of gold and you find out that it costs $5.75 for every 0.01 grams of gold. And you have a ring, and when you mass that ring, it's 7.62 grams. And you mark it as being an 8-gram ring. What's the problem with that? Well, the problem is that you're going to end up paying a lot more money for that particular ring, because by dropping off these 2 digits and rounding up, you're losing what we call significant digits. So let's talk about when digits are considered to be significant. If a digit is not a 0 value, it's considered to be a significant digit. If numbers are exact numbers or counting numbers, they're considered to be significant digits. If we have things like conversions, saying that 2.54 centimeters equals 1 inch, or talking about pi, 3.14, those are examples of exact numbers which are considered to be significant. Now, there are other rules that talk about when numbers are significant, and there are lots of wordy things that are sometimes hard to follow. So what I'm going to do is give you kind of a trick that will work every time to figure out how many significant digits you have. So let's say that we have a picture of the United States. I know it's not a great picture, but it'll work. Think about what ocean is to the east of the United States. And that ocean is the Atlantic Ocean. And if we look at the ocean that's found to the west of the United States, we're dealing with the Pacific Ocean. You're like, what does that have to do with figuring out significant digits? Well, we're going to use the United States like the number that we're trying to determine the significant digits for. The A is going to talk about whether or not a decimal point is absent. And the P is going to talk about whether or not a decimal point is present. So let's say we have a number like 2,500. And we're asked how many significant digits are in that number. Well, the first thing we're going to do is decide whether or not a decimal point is present or absent in the number. And when we look at this particular number, there is no decimal point. That means the decimal point is absent. So we're going to start at the Atlantic side of the number. And the first digit that we start counting with is the first digit that's not a 0. And then every digit after that digit, no matter what it is considered to be a significant digit. So when we look at this number, it has 2 Sig Figs, or significant figures or significant digits. Let's say we've got 3040, and we want to find out how many significant digits there are. Well, again, there is no decimal point in the number, so we're going to start from the Atlantic side of the number. The first number we count is the first number that's not a 0, and every digit after it. So in this case, we're going to have 3 Sig Figs. Here's another example. Let's say we've got 100.0. Well, now we're looking at a number that has a decimal point present. So we're going to start from the Pacific side of the number this time, and the first digit that's not a 0. And then every digit after it, no matter what it is a significant digit. So this number has 4 Sig Figs. Here's another example, 0.00340. All right, it has a decimal point, so we're going to start on the Pacific side. And the first number that's not a 0 from the Pacific side is the 3. Every digit after it's considered significant. So this number has 3 Sig Figs. So we need to be able to look at a particular number and decide how many significant figures that number has. And then we're going to use some rules. When we talk about multiplying and dividing, a lot of times when we plug those numbers into the calculator fills up with numbers and we don't know where to round to. The rules for significant digits state that the number of significant digits in an answer is the same as the number with the least number of significant digits. So we count up how many significant digits there are in the numbers that we're multiplying or dividing, and the least number of digits determines where we're going to round our answer to. So let's talk about adding and subtracting. A little bit of a different rule when we add and subtract. So we take the numbers and we plug them into the calculator, whether we're adding or subtracting, but this time the only thing we're going to look at is how many decimal places there are, not how many total significant digits there are. So if we were to look at two numbers and we add them together, when we're done, we find out how many significant digits in each of those numbers. The one with the least number of decimal places determines how many decimal places we're going to have in our answer. So let's look at an example. Okay, let's say that we've got the number 1056 and we want to decide how many significant digits there are. Okay, so think about whether there's a decimal point present or not, what side of the number you're going to start from, and how many significant digits. Okay, so we should have 4. Okay, here's our next number. Decide whether or not there's a decimal present, whether you start from the Atlantic or the Pacific side, and then how many significant digits. So we have 1. All right, now this number has a decimal in it. So what side are you starting from? And how many significant digits do you have? So 4. And let's look at one more. Okay, this time again we've got a decimal point present. So what side do we start from? What's our first significant digit? And how many total digits do we have? So in this case, we have 3. So now we're going to do a couple of practice problems. Let's say we've got 2.002 times 3.42 times 5. And the first thing we would do is multiply all those numbers together in the calculator, and then look at what the calculator comes up with for an answer. So plug those in. So the calculator says 34.2342. That answer has too many significant digits. So we're going to look at the answers that we're multiplying together. We have 4 digits here, 3 digits here, only 1 digit here. So when we multiply, we're going to round to the least number of total significant digits. So in this case, we're going to round the number to 30. And we don't want to put a decimal point because then that would give us 2 significant digits. So let's do this. We're going to take 703.2 plus 34.223 minus 21.45 and plug that all into the calculator. So do that. The calculator says 715.973. But again, that's too many significant digits. In this case, we want to look at how many decimals we have to decide where to round. We have 1 decimal here, 3 decimals here, and 2 decimals here. Our rule for adding and subtracting is we're going to round to the least number of decimal places. So in this case, we're going to round to 716. Notice again that in the calculator, the next digit after our first decimal is a 7, which would round the 9 up, which would give us 716.0. So let's look at our last one. We have 34.2 times 25.3 plus 133.2. So we would do our PEMDAS rules, which we should remember. Multiplying comes first. And then we're going to round that answer, and then we're going to add and use the rules for adding. So see what you get for your calculator answer and decide where you want to round off. Okay, so we want to round off to 866.